Math 1314, section IC1, spring 2022, Tyler Junior College, section 1.5, linear inequalities, video 1, basic inequalities. Before you start this video, if you have not done so yet, you need to go into McGraw-Hill campus and complete the weekly work, the Math 0314 weekly work 02 assignment, because the skills that are reviewed and practiced in that assignment are going to be used in this series of videos and the next series of videos. Not having those skills at your disposal will make it difficult to follow what's going to happen in these videos. So again, if you have not worked on or completed the Math 0314 weekly work 02 assignment in McGraw-Hill campus, I strongly advise you do that before moving on. Also, before moving on, I'm going to plug in my headset.
The microphone picks me up a little bit better. I'd be lying if I said I'd never done that before. Okay, so what do we mean by basic inequalities? Well, I'm assuming by now you know greater than, less than, greater than or equal to, less than or equal to. So we're going to jump right into solving basic linear inequalities. For example, let's solve 3x plus 1 is greater than, I don't know, 28. We'll do that. If this were just a linear equation, meaning it said 3x, let's make that a little bit, 1 second, folks. I'm going to do something real quick. Okay, the font size there is good, but when I draw, let's make this line a little bit thicker. If we were to solve something like 3x plus 1 equals 28, by now we know the moves to do that. We would subtract 1 from both sides, cancel the 1s, leave 3x equals 27, and then divide both sides by 3 so that we can cancel the times 3 and isolate the x. 27 divided by 3 is 9. So what's the difference between solving an inequality and an equation, and specifically a linear inequality or a linear equation? Well, the answer is not how it begins, but how it ends. If we were to solve the inequality 3x plus 1 is greater than 28, we would start by doing the exact same moves that we just did for the corresponding equation. Our goal is still the same. Excuse me, isolate the x. So our first move would be to subtract 1 from both sides. When we do that, the 1s still cancel. That still leaves us 3x greater than, and then 28 minus 1 is 27. 1 second, folks. Sorry, folks, I had an issue I had to take care of, and so my train of thought got interrupted a little bit, but I know that we were in the process of solving the corresponding inequality, and we started it the same way that we started the equation, by subtracting 1 from both sides. And of course, we're going to finish this by dividing both sides by 3, and we get x is greater than 27. Excuse me, x is greater than 9. So as you can tell, solving the inequality was pretty much exactly the same way that we solved the equation. The only difference is we had a greater than sign in the middle instead of an equal sign. So it kind of works the exact same as an equation. I say kind of because there are some differences down the road, but it's a little bit different in terms of how the problem ends. Let me show you what I mean on the next page. We just solved the inequality 3x plus 1 is greater than 28, and our answer was x is greater than 9. But as was reviewed in the weekly work for this week for Math 0314, the assignment I alluded to previously, we have multiple ways that we can represent this solution. We have 3 ways, in fact. We have set builder notation, which is almost what we have written here. We have a number line, and we have an interval. In your homework, you could be asked for any of those at any time, so you're going to need to be able to take your solution to this inequality and write it in all 3 ways. Let's start with set builder notation. Set builder notation was actually pretty easy. All you had to do, and if you missed this, go back to that assignment, the weekly work 02 assignment for Math 0314. The set builder notation is writing your solution as a set or a collection of objects in a pair of braces. You start by saying the set of x's, and then the vertical line translates to the phrase such that, and then you type the condition the x's have to satisfy, which in this case is x is greater than 9. Then you close off your set with the brace. So really, set builder notation is just a fancy way of saying what we just got. However, we also had to come up with a number line. And the reason we can come up with a number line is because when you solve an inequality, you don't get a single value for x. You get an infinite number of values. When you say something like x equals 9, you have one answer only. But when you say something like x is greater than 9, you have an infinite number of solutions. Any number greater than 9 makes this true. 10, 11, 9.1, 5 trillion, or any other number as long as it's greater than 9. Since there's an infinite number of solutions, technically we can represent them visually. All we have to do is get a number line, locate the number we're concerned with, and if it's only a single value like 9, then you can just drop it in the middle. Because we're talking about greater than 9, those would be the values to the right of 9. So we would shade to the right of 9. Let's do this. I can draw something a little fancier than that. We would shade to the right of 9. But what would we put on the 9 to indicate that it is not part of the solution set, since it's x is greater than 9? When your inequality is strict, when it's greater than or less than, as opposed to greater than or equal to or less than or equal to, the symbol you put on the end point of the number line is a parentheses. And so as a number line, it would be open parentheses on the 9 and then shaded to the right forever. But what about an interval? An interval is just a description of what you shaded in on the number line. You always write your interval from left to right, and you use brackets or parentheses depending upon whether or not you want to include the endpoint. Our interval starts at 9 and goes all the way to the right forever. And remember, that's like saying it goes to infinity. Because we do not include the 9, we put a parentheses on the 9, and you always put parentheses on infinity because you can't get to infinity. It's not a destination, it's a journey. It says it goes forever. So when you're solving an inequality, be prepared to give any of these 3 variations of the solutions. Let's take a look at one, maybe 2 more. Let's see, let me come up with a good one. Hold on for a second. Okay, I think this one's pretty fair. Solve the inequality. 4 times open parentheses x minus 2, close parentheses, plus 3 is less than or equal to 2x minus 7. All of the same issues we had when solving linear equations can be issues when solving linear inequalities, parentheses, variables on both sides, and yes, even fractions. But we've already discussed that quite a bit in the previous series of videos, so we can just do the same things we did before. When you're solving an inequality, you're almost always doing the same things. When you're solving a linear inequality, you're almost always doing the same things as if you're just solving a linear equation. In this case, our first move would be to distribute the 4 across the parentheses to free up the terms inside. 4 times x is 4x, 4 times negative 2 is negative 8. All the other terms stay the same, so we still have the plus 3, the less than or equal to, the 2x, and the minus 7. Remember, when you distribute to eliminate parentheses, you often create like terms to combine. In this case, we can combine the negative 8 and the positive 3 on the left side of the inequality to get 4x minus 5 is less than or equal to 2x minus 7. Now we need to address the fact that there's an x on both sides. You'll never get to your goal as long as you have an x on both sides of your equation, or in this case, inequality. So we're going to subtract the smaller of the 2 from both sides. That means we're going to subtract 2x from both sides. And as a consequence of that move, on the left, 4x minus 2x is 2x. We still have the minus 5, less than or equal to. On the right, the 2x's cancel, and now we have a negative 7. Let's move this to the next page and continue. Continuing, now that we have a single x in the inequality, now we just have to finish solving. Add 5 to both sides in an effort to get the x by itself. That leaves us 2x on the left. The 5's cancel, less than or equal to. On the right, -7 plus 5 is -2. And then our last move to get the x by itself is to divide both sides by 2. Since the x has a 2 multiplied in front of it, the 2's cancel. That leaves an x on the left, less than or equal to. And on the right side, -2 divided by 2 is -1. If we wanted to write our solution all three ways, set builder notation, I could practically just take the inequality that you see there, put a vertical line in front of it preceded by an X, and then put braces around it. And that would be our set builder notation. I'm going to remove it there and write it off to the side, because when I save this as a PDF, I want the original solution by itself. So set builder notation would be the set of, move this bar over, x's such that x is less than or equal to -1. I know I typed less than. The word processor in Zoom will not allow me to type less than or equal to, but I can draw a little line under it to make it say less than or equal to. Okay, so how would the number line look? Can you describe the number line to me? What number would I look for? Which side of it would I shade? What would I put on that number? Well, the number we're looking for is the number 1, because, the number -1. And when you're only putting a single number on a number line, you can put it wherever you want. Because we're looking for numbers that are less than or equal to -1, less than means to the left, so we would shade to the left. But what would we put on the -1, a parentheses or a bracket? Because it says less than or equal to, we would put a square bracket on it. And it would look something like that. What's our interval? Well, the interval is just the description of what you shaded in from left to right. So from left to right, our interval, our number line is shaded starting at -infinity, which always gets a parentheses, comma, stops at -1, which has a bracket because it said less than or equal to. So up until now, solving a linear inequality is just like solving a linear equation, at least from the beginning to the end when you get the x by itself. The only difference is afterwards, you have 3 ways to represent your solution, using set builder notation, using a number line, and using an interval. Be prepared to give any and all of those in your homework. In the next video, we'll talk about one of the things that makes solving a linear inequality different than solving a linear equation.